Hey everyone, welcome to Blunt Talk. Today we're going to be exploring the differences between cannabis geno, pheno, and chemotypes, key concepts that are essential for making informed cannabis decisions. By the end of this, our hopes are that you will not only be able to define these words, but you will also understand how these ideas relate to the very common labeling of sativa, hybrid, and indica, and how these distinctions can help you navigate your cannabis journey and find what works best for you. This episode is a little bit more in-depth and the subject matter is a little bit more complicated. So in the description, I will leave timestamps so that if you need to go back to any of these segments, it will be super easy for you. Other than that, grab some smoke, a snack, a journal, and let's get to the bottom of this. Cannabis has been woven into human civilization for millennia, serving diverse purposes across cultures worldwide. While misconceptions have clouded our understanding of this versatile plant, one aspect of this amazing flower that has received thorough scientific scrutiny, its biology. Let's start at the beginning. All living organisms on Earth have a genotype, a genetic blueprint containing the potential traits that an organism can possess. Cannabis plants, like humans, are diploid, meaning they receive one set of chromosomes from each parent. This gives them a diverse gene pool with many possibilities. Consider the physical differences observed among siblings. While they inherit the same set of genes from their parents, the ultimate expression of these genetic possibilities can vary considerably. For instance, in my own family, I present as the tall sibling with very curly brown hair, while my sister Mindy is notably shorter with straight blonde hair. These different physical characteristics arise due to the complex interplay between the individual's genotype and the environmental factors that shape their development over time, such as lifestyle, diet, and climate. These same principles apply to the cannabis plant. Let's explore real quick some of the key factors that can drive differential trait expression from these genotypes, even when their underlying genotypic composition are comparable or exactly the same. To keep it simple, let's break down these key factors into three categories: light, climate, and nutrients. First up, light. When it comes to light, the intensity of the light source directly impacts bud density, sculpting the very structure and fullness of the flowers. Meanwhile, the specific light spectrum exerts a huge influence over the plant's morphology, its form and architecture, if you will. Lastly, and probably most important, the duration of the light exposure plays a crucial part, directly impacting the onset and progression of the flowering stage. By manipulating this variable, the grower gains control over the plant's growth cycle, steering transition between vegetative and reproductive phase. Secondly, let's explore climate, specifically temperature and humidity. Temperature has a fascinating effect on coloration. When temperatures drop below 60 degrees Fahrenheit, plants often develop rich red, blue, and purple hues due to an increased anthocyanin production. Conversely, higher temps can break down chlorophyll, resulting in lighter green or yellow coloring. These responses can actually cause two identical plants to display dramatically different characteristics, something we're going to cover in depth here in a moment. Humidity stands as a critical factor in its own right. Not only does it significantly influence terpene expression and nutrient uptake, but it may be the most crucial element for preserving both the terpenes and cannabinoids in the plant. Among all growing variables, humidity proves particularly challenging to perfect. High humidity can enhance vegetative growth through increased nutrient mobility, while lower humidity during flower can stress the plant into producing more resin as a protective response. A miscalculation on either end can cause illnesses or even death for the plant. Lastly, let's talk about nutrients real quick. For cannabis, nutrients play a massive role, not only in the growth of the plant, but the synthesis of its cannabinoids. Macronutrients such as nitrogen for vegetative growth, phosphorus for root and flower development, and potassium for overall growth help build the physical traits of the plant, while micronutrients such as calcium, magnesium, and zinc impact more of the terpenes and cannabinoids, affecting flavor, aroma, and effects. Tying this all together, the proper management of pH is essential for soil or medium. If the pH isn't in the ideal window, nutrient lockout is inevitable and the plant will either yield less than expected or even die. All three factors, light, climate, and nutrients, play a pivotal role in trait expression within the cannabis plant. Any changes in these core elements can cause the plant to react in dramatically different ways. So, what do we call it when a specific genotype encounters a new environment and expresses traits that differ from plants with the identical makeup? We get phenotypes. So, now that we've explored the intricate world of cannabis genotypes, let's explore how these genetic instructions manifest in the living plant, which is the phenotype, the observable expression of genes when they interact with their environment. Most of us have known them by the name Sativa, Hybrid, or Indica, but it's so much deeper than that. Most breeders and growers usually break phenotypes down into three distinct categories, each playing a crucial role in how the final product looks and affects you. First, we have morphological, the physical characteristics we can observe. This includes everything from the plant's architecture, leaf patterns, to the density and structure of the flower. Then there's performance, which encompasses the plant's growth characteristics and behaviors like flowering time, yield potential, and environmental resilience. And then finally, we have chemotype, arguably the most significant for both consumers and breeders, but especially consumers. These determine the plant's chemical profile, the precise balance of cannabinoids and terpenes that create specific effects and therapeutic properties. This also covers the flavor and aroma. When breeders are searching for exceptional plants, they evaluate these three phenotype categories through a process called phenohunting. They'll grow multiple strains from the same genetic cross. This is why you'll often see numbers after names. It's literally marking which phenotype was the winner out of that genetic line. Gorilla Glue number 4, more commonly known as GG number 4, is the perfect example of this process in action that will hopefully reel this all in. So, when comparing different phenotypes from the same genetic parents or genotype, Gorilla Glue, the breeders evaluated each plant's morphological traits, looking at the structure and resin production. They assessed the performance, tracking growth rates and yields, and they tested chemotypes, analyzing cannabinoid and terpene profiles. While GG number 1, 2, and 3 might have excelled in one or two categories, it was number 4 that hit the trifecta. The crucial thing to understand with phenotypes, and we'll just keep using GG4 as an example, unless you're getting GG number 4 directly from the original breeders or their verified cuts, you're getting someone else's interpretation. Even with the same genetic parents, it's a different phenotype altogether. This is why, like me, you have probably tried GG4 and Sativa, Hybrid, and Indica, or this is why one of your favorite strains may be completely different from the last time you tried it. If literally anything in the grow changes, these strains will be different. This brings us to an important paradigm shift in the understanding of cannabis. First off, never trust the name. Just kidding. But it's actually becoming more widely accepted that the terms Sativa, Hybrid, and Indica, while deeply ingrained in the cannabis culture, are actually oversimplified distinctions that tell us very little about a plant's therapeutic potential. These terms originally described plant morphology and geographic origin alone, not effects. So in this next statement, let's explore what we've been told about these classifications over the years and discover new insights that are helping to better guide our journey, moving beyond these old worn-out tropes. First up, let's explore Sativa, breaking down traditional beliefs versus modern understanding. So what we know, some of the traditional physical traits, they can grow up to 20 feet tall, they can have distinct narrow finger-like leaves with sharp serrations. Their buds are usually airy and less dense, and most of the time they're actually lighter green in color. So some of the commonly assumed effects attached to sativas, they're energizing, mental clarity, enhanced focus, creativity. They are typically marketed as the perfect daytime strain. Using what we learned in the previous segment though, environmental factors heavily influence final outcome, from color changes due to temp variations to overall effects. A sativa genotype doesn't guarantee traditional sativa-like effects. In fact, some myth-busting examples would be Jack Hare. The myth is that it's a pure, energizing sativa. The truth is that most of the phenotypes are actually myrcene heavy, resulting in relaxing effects. Durban Poison, another one. The myth is that it's a classic pure sativa landrace. Well, that's true, but the real truth is that it's higher in linalool content and can actually make it surprisingly sedating and Because it's a landrace, the cannabinoid and terpene profile is more balanced due to the lack of it being watered down, so it doesn't feel like your racy sativa that you're usually hearing about. Next up is Chocolate. The myth: it has a coffee-like energy boost. The truth is, a lot of the time, its high myrcene content leads to balanced, relaxing effects, and it's literally won an award for being a well-balanced high. Now let's discuss indicas, which I thought were my favorite, but after this episode and after everything I'm learning, who knows? Um, so some of the traditional physical characteristics of indicas: they're usually short and sturdy, typically under 6 feet. They have very broad, deep green and bushy leaves. Their buds are incredibly dense, frosty, and incredibly sticky. And their colors range from the prettiest of greens to the darkest of purples. And some of the common assumptions are that they have heavy sedation effects, they are sleep aid, pain relief, increased appetite, the quintessential nighttime strain. So some of the indica strains that break the stereotypes would be Northern Lights. Its popular belief is that it's a classic couch-locking indica, but in reality, a lot of the cuts are actually high in limonene, which can be surprisingly uplifting and can be used throughout the day. Hindu Kush is an indica landrace, so it's usually believed that it's completely sedating, but in reality it has a very balanced terpene profile, which causes it to be very present in mind while also being in the body. I personally love smoking Hindu Kush in the morning. That's just me though. And then Granddaddy Perp, or GDP, that one is usually known as the quintessential nighttime strain, but that one actually has another complex cannabinoid profile that makes it very giggly and very uplifting. I actually have a frequent patient that eats GDP RSO with his Cheerios, and it's the only thing that gives him the energy that he needs for the day. Lastly, Bubba Kush. Probably one of my favorite ones, just because Kushes, usually most people tend to believe Kushes are couch locking or they put you right out, but this one actually is very high in pinene a lot of times, so it makes it more clear-headed than expected, and it's actually one of the only few Kush strains that doesn't couch lock you, so it's actually really fun. As far as hybrids go, nearly everything on the market today is a hybrid, so I'm not really going to touch on those just because they can literally manifest in any way, but they do kind of drive home the fact that different ancestral traits can be pulled from all different kinds of variables, so that's pretty cool. And although the examples I used aren't that extreme, because most people would just call them a sativa hybrid or an indica hybrid, countless cannabis strains have been mislabeled or marketed under different names, leading to confusion about their true identity. This highlights why understanding a strain's terpene and cannabinoid profile is so crucial. By knowing these key components, you can still find similar effects even when your favorite strains become unavailable, using their chemical makeup as a reliable guide to discover new alternatives. Well, that's all I have for you today. Today we took a deep dive into cannabis genetics from genotypes to phenotypes and busted, hopefully, some myths about sativas and indicas along the way. But this is just the beginning of your cannabis education journey. Coming up, we're going to be breaking down every major terpene and cannabinoid in detail, each getting its own dedicated episode. Think of today's knowledge as your foundation. Once you understand how these chemical profiles pair with what we learned about genetics, you'll be equipped to make much more informed decisions about your medicine. No more guessing games based on outdated labels. Instead, you'll understand exactly what compounds work best for you. So stay tuned for next episode where we'll get into the nitty-gritty of each terpene and cannabinoid. As always, keep learning, stay curious, and we'll see you in the next one. Oh, and last thing before I go take the biggest dab of my life, check the description for any literature we may have on any of this stuff, and also check for links of our website for some of the coolest cannabis swag you can get your hands on. Also, like and subscribe if you want to, and if you don't, I still love you. I'm Jacob. Peace.